Time value of money is simple yet very useful concept that we're gonna use extensively in our decision making. So in short, it states that the money have a different value in time. So if I have a $100, it is not equal to the $100 1 year because I can actually put them into savings and get some money back. And that's why we cannot compare the nominal values when we are talking about nominal values from different years and different points of time. So in order to explain you that, let's have a look at an example. So let's imagine that we have $100 today and its nominal value will not change during time. So in 1 year, it will be still $100. And in 2 years, obviously, it will be again $100, but in nominal value. The real value is, however, different because if I have $100 today, I can put them into the saving account, get some interest rate. So actually, the $100 today are worth more. And to show you that, let's look at an example. So let's imagine that every year you can get 5% interest rate. This would mean that the $100 that I get today are actually worth $105 after 1 year because I'll get 5% on the 100. So this is $5 additional. And then in 2 years, it will be actually worth 110. In other words, the 100 today are worth 105 tomorrow and 110 in 2 years. We calculated using a very simple formula. So this is just the nominal value multiplied by 1 plus the interest rate. So the 5% and then to the power of the number of years that elapsed from this moment where we had the nominal value till now. So this is just 1 year. So that's why we've got 1 here. But in the case of what happens after 2 years, we have 2 because it's 2 years elapsed after today. So as you can see, this is a very simple example. And in this way, you can see that the $100 today are worth more in 1 year and even more in 2 years, obviously in real times, because I can put it into saving account. The opposite is obviously true. So 100 that I will get in 1 year, it's not worth 100, but it's worth less. So let's look at example where we get 100 in different periods. And now we want to see how much the 100 that I will get in 1 year, how much it is worth now. And the same goes for the 100 in 2 years. So again, let's assume that we have a 5% interest rate. And after some calculation, you will discover the following thing. So the 100 today are obviously worth 100, but the 100 tomorrow, they are worth only 95. And we get it by reversing the previous formula. So as you might remember, was nominal value multiplied by 1 plus the interest rate. And here we simply divide by that. So we have nominal value divided by 1 plus the interest rate and then to the power of 1 because this is just 1 year between today and the after 1 year point of time. In the case of 100 that I will get in 2 years, they're worth even less. So they're worth only $91 expressed in current value. And I get it by dividing the nominal value by 1 plus r to the power of 2. If we had year number 3, we would have the nominal value divided by 1 plus r to the power of 3 and so on and so forth. So in other words, this shows us the present value of the 100 that we get in different periods of time. So the 100 that I get today are worth 100. The 100 tomorrow are worth just 95 in current value. And the 100 that I will get in 2 years are worth $91. Obviously assumed this interest rate. Now let's have a look at some calculations in Excel that will show you how we got this number. We're going to use them later on in order to make more complicated decisions. Let's try now to calculate the time value of money from the example we have shown you in the previous lecture. So please open file attached to the lecture, which is called NPV. And here in the sheet master, you will find a table of content. We're going to start with the first sheet time value of money. And here we have, as you can see in row 5, the nominal value of 100. Every column is a separate year. So J is year number 1, K number 2, and L year number 3. So we start with calculating the future value of 100. And as you might remember, we said this will be equal to the nominal value, so 100. Then multiply, as you can see, 1 plus r. So in this case, this is the interest rate of 5%. That's how we got 105. And in the third period, we do exactly the same thing. So we get the value from previous year, and then we multiply by 1 plus r. We can as well have the nominal value multiplied by 1 plus r to the power of 2. Now, when it comes to the present value of 100 that I get every year, we have calculated this in row 13. So as you might remember, it's 100, 95, and 91. And here we have the exact formula. So as you can see, he gets the nominal value and then he divides it by 1 plus interest rate. And to the power of number of years we got between this year and the first year. So just let's have a look at the components. So the nominal value is obviously 100, then interest rate is 5%. And then between this year, so in column K, we've got second year and the basic year. So in column J, so number 1, we have just 1 year elapsed. That's why we have in 95 being the 1 plus r to the power of 1. And in the column L, we've got 91 because we have 2 years between year number 3 and year number 1. You can also try to go back to the nominal value. And this is what we did in the row number 19 using the formula I've shown you in the slides. So we get the present value, we multiply it by 1 plus interest rate, and then to the power of years that are elapsing between the year in question. So in this case, year number 2 and the basic year. So from 95, we go back to 100, and from 91 in 2 years, we go into 100 as well. In other words, you can read it in the following manner that if today you got $95 and you put them into a saving account, you would get at the end of year 2 $100. And again, if you had 91 and you put them into a saving account for 2 years, you would get $100 as well.